In this video, this is the last of the 3 iterations of version 2 of calculating the average of 3 numbers. And by the end of this video, we're going to actually see the makings of a pretty scalable algorithm that looks like probably what a professional C programmer would come up with if they're going to come up with an averaging algorithm. So it's exciting, right? All these steps are finally going to lead us to this interesting answer. It starts as always by double-clicking on the terminal, and then cd space desktop, and then cd space C code. Then I want to make a new project, /makeproject.sh space average underscore v2c, version v2c. This is the third of version 2, the third type of version 2 of the average program. Then we cd into average underscore v2c, open dot, and we can double click on average v2c. Then I do the trick where I'm going to get average v2b, so I go file, open recent, get average v2b.c, and then in average v2b.c I command A, command C to copy everything onto there, and then I go into average v2c, average v2c.c, and then I command A, command V to use average v2b as my starting point for this particular program that I'm going to write. Okay, so here what I'm going to do is I'm going to erase the second and third times we added sum equals sum plus a sub I equals I plus 1. Erase those two. So I have one left. I encase those lines with curly braces, and then before the curly brace I put the following statement: while open parentheses I less than 3. This is a loop, and looping structures are a very powerful tool in C programming. This is one kind of looping structure, the while loop. We initialize I equal to 0. Sum is also initialized to 0. And as it scrolls through, the first time it goes through, I will be equal to 1. The second time it goes through, I will be equal to 2. The third time it goes through, after the third time it goes through, I will then be equal to 3. 3 is no longer less than 2, and so it will pop out of that. What the while statement says is, as long as the condition inside the parentheses is true, do whatever's inside the curly braces as many times as until that condition is no longer true. So this is going to work. This is going to work the same way as the version v2b is, but we only had to type out sum equals sum plus a sub I once, and I equals I plus 1 once. A little nuance here is that I put the I equals I plus 1 below the printf statement, so I in the printf statement, in that diagnostic printf statement, is going to go from 0 to 2, not 1 to 3. And then also I put a printf statement before the loop happens just to show that what the initial values of sum and I are going to be. And I put a little printf statement saying this is before the loop. This next one below here, this is before the loop starts. So using printf statements like that can help you see your way through what comes out at the end on your terminal. All right, then we go back to the terminal, we compile it, gcc space average underscore v2c.c dash o space average underscore v2c. Then we run it /average underscore v2c, and you can see that it says before the thing starts, sum is 0 and I is 0, and then we see 0, 3, 1, 8, 2, 16. Right? We see the evolution of sum and a sub I as they go through this while loop. We only had one printf statement like that inside the loop, but it printed out 3 times. That's how a loop works. And we get the same answer, 5.333. So this algorithm works the same as all these other algorithms that we've seen so far. Wow, a loop is a pretty useful tool. Oh my goodness, it's useful. The next thing I'm going to do is I'm going to just take out all the diagnostic printf statements so that we can see that it actually works the same way. So I just did that real quick, and you can see that when you do that and recompile it, then it works the exact same way. There's another thing that we need to learn about, which is the command I++. For integers, you can do I++. That's just a shorthand for saying I equals I plus 1. If we replace I equals I plus 1 with I++, and then we compile it and run it, we're going to get the same answer. It works the same as I equals I plus 1. I++ means increment I by 1. Another smug point about C programmers is C is the programming language. They actually, back at Bell Labs, it was created in Bell Labs way back when, in the 60s, I think, or 1970s. And Kernighan and Ritchie came up with it. Kernighan came up with it, and he came up with version A, version B, and version C. That's how we came up with the name C for the C programming language. The second iteration of C, which was an attempt to make C more robust and less error-prone, was called C++. So incremented C just by a little bit. That's the smug type definition of the second generation of C programming languages. C++ is just C incremented a little bit. So using ++ is a very common strategy in writing code. At this point in the video, people who are coders, like teachers of code, are going to go, Olson, why are you teaching while loops, man? The while loops aren't really the most commonly used. They're used, but just not that much. What's much more commonly used is a special kind of loop called the for loop. And that's shown here in this code. And the for loop, there are 3 statements inside the parentheses. So instead of while and open parentheses, it's for, F-O-R, and open parentheses. There's 3 statements separated by a semicolon. The first statement is the initialization of the index, I equals 0. The second statement is the conditional statement, just like in the while loop, I less than 3. And the third statement is incrementing the index, I++. So you don't have to have I++ inside of a for loop. It's inside the for statement itself. And so inside that for loop, there's only one command, A equals sum equals sum plus A sub I. You don't have to do I++ inside the for loop. This is shorthand. The for loop is just a special kind of while statement, I equals 0, while I less than 3, then I++ inside the loop. It's just a different way of saying the same thing. But the for loop is in math type programming, the for loop is probably more common than the while loop, and so it's good to teach. It's good to know both, but the for loop is very common. So you have to have those 3 statements inside the parentheses separated by semicolons. When we compile it and run it, it runs just the same as that while loop statement, so functionally there's no difference. The loop has transformed our ability to come up with a scalable averaging algorithm. Thinking now that we have a loop and we can see this, to change the algorithm from 3 numbers to more numbers, it's not going to take that many changes to the code. Let's do it. Let's do the average of 5 numbers, not 3. So I gave a sub 3 a value and a sub 4 a value, shown there in the code. I had to change in the for loop, I had to change I less than 3 to I less than 5. And in the average equation, I had to say sum divided by 5, not sum divided by 3. So those are the 3 small changes that we had to do. And I did in the declaring the variable, I had to declare the variable as being 5 elements long, not 3 elements long. 4 lines. I had to just change 4 lines, and lo and behold, I compile it and run it, and it comes up with the right answer too. This is a scalable algorithm. This is an algorithm that you can see being scaled, and you can imagine variables for the number of points that you have. So not 5, but n for the number of points. And you can start to see that this is really going to become a scalable algorithm. We're going to be able to do, with variants of this, thousands of numbers, and with a couple of little tweaks to that, billions of numbers probably. So we're getting close to coming up with a really robust and scalable algorithm. And this is the major step here, understanding how loops work. That's the punchline of this video.